1.
Hello, I'm Mr. Sean here at UEI Reseda College. I'm going to be doing a quick rundown for our GFCI lab today. Key thing right off the bat is to notice, first of all, my name, email, phone number, date, module, which is solar applications. We're in Unit 4, this is Lab 1, okay? In addition to that, we have our objectives clearly written right here. So wire a GFCI for protection of itself and protection of devices. Explain how a three-way switch works. Explain how a single pole switch works. Explain how to make a duplex receptacle into a half-hot or switched outlet and install a basic light fixture. So with that being said, I wrote the diagram on the board for the students to understand how it should look, okay? So we got our GFCI, our three-way, light, three-way, half-hot, and our single switch. So the key thing to keep in mind is on the GFCI, you have a line and a load. So on the line side of the GFCI should be pigtailed for the hot for the switch and for our lighting and switches for the three-way. In addition, it has the load side of the GFCI. On that load side, it's going to go to our half-hot. All right? So now we're going to look at the curriculum over here. And as you notice, per the curriculum, it shows you clearly right here the objectives as I've written on the board and the required tools necessary, which all my students have, including myself, and the material required. Okay? Now, to the actual project board itself. As you can see, just as it is on the board, GFCI, single pole switch, regular duplex outlet, three-way light. Okay, so now I'm going to just turn it on just to show the testing purposes of it, make sure that everything's working correctly. Okay, so I'm going to plug this in. Obviously, I'm going to wear my PPE, make sure that we're being safe when we're working anything hot or live. Okay. So as we can see as of right now, we have this light's on and this light's on. So that means that this circuit right now is constant, okay? They are not switched by any means. The only thing that's gonna be switched is this part of the duplex outlet, which is a half-hot. So as you can clearly see, when I turn on the switch, the light comes on. Turn it off, goes off. And then very simply put, for the GFCI, or for the three-way, excuse me, turn on the light comes on, turn it off, this one works, or if it's on, this one will turn it off, vice versa, right? So that's it for that. I'm gonna turn this off and unplug this. So, let's take these out. One thing to note right off the bat, GFCI, ground fault circuit interrupter, right? Ground fault circuit interrupters all have to have the ground attached to it. It will not work if there's no ground, okay? So that is the key thing about the ground fault, okay? Has to have the ground. Now, food for thought on that, if, for instance, you didn't have grounds for your outlets, okay? You could also use a GFCI breaker, which essentially would be like a GFCI outlet. So in the case of, if you didn't have grounds, you can actually use a GFCI breaker to properly protect your duplex outlets if you didn't have a ground. Just food for thought. There's one other thing I actually wanted to demonstrate, so I'm gonna put my glove back on here. Plug this back in. I'm gonna use this tester to show the example what happens. Okay, so right now my switch is on, my plug is hot, but if I push this button, it's gonna trip my GFCI, right? So GFCI tripped, so we know that it's working properly, that everything's grounded. If everything was not grounded properly, that wouldn't have happened. So I'm gonna reset my GFCI. I might have actually tripped the whole circuit all the way down the line. That's fine, we're done for the demonstration of doing it live anyway. But normally speaking, you would reset it just by pushing the reset button, simply put, right? Okay? couple other things to mention or notice. Let me get a drill here. Okay, anytime you're working with metal boxes and metal mud rings, you want to have black tape on the switch or any device to cover the screws, because if for whatever reason you have to pull the switch out, you don't want it to hit the side. Okay, so it's just one extra thing we can do for safety. Just put some black tape around your switch or your outlet. It ensures a lot more quality as well. It shows the kind of electrician that you are. You put a little extra effort into safety, because you're looking out for the other guys too, not just yourself. In addition to that, let's see. Oh, okay. So let's explain the half hot. Okay, so notice on the half hot, for this instance, okay, on the neutral side, we have the bridge that connects these together is still connected, so that's fine. But on the other side, for the actual hot portion, the bridge is disconnected. We actually used cutters and disconnected it. So that way this is hot at a different time that this is hot. So depending on how you wire it, whether it's this one or that one, just depends on the scenario. So that's just an example of the half hot, okay? Also, key thing to point out, just when we think about code, right? We hear a lot of different things in code and field talk or terms. So most common folk, they will call this a light bulb or light, right? Or bulb. This is actually called a lamp, this one specifically, okay? So this is just a lamp, okay? This is the lamp holder, right? So lamp holder, lamp. Now when this is all connected into one whole unit, this would be considered a luminaire, okay? So a lot of guys might not understand what a luminaire is. Hopefully that will sum that up for you. As far as that goes, is there anything else I'm missing? Oh, just simple food for thought as well. As far as code, we need at least 6 inches coming out of the box, okay? Now, if you come here to the code, right here, it's 300.14, and it says length of free conductors at outlet junctions and switch points. At least 6 inches of free conductors measured from the point in the box where it emerges from its raceway or cable sheet. Okay, so a lot of guys, the misconception is it starts from here, the wire, okay? But it actually starts where it comes into the box, where it emerges, okay? So we'll just keep that in food for thought and keep that table in your head, or the code in your head. And as far as that works, I think we're all set. The only other key thing I just want to point out, let's just do it real quick. Okay, so for the 3-way wiring, let me take the tape off. Okay, so for our 3-way wiring, they call it a 3-way because there's 3 screws, not because it's 3 switches. Key fact, all right? In addition, this is your constant hot, which is on the black screw. That's your constant. Your 2 gold screws are going to be your travelers. And then the same thing over here, except that this is not a constant hot, this is a switch leg that actually goes to the light. And then again, the 2 gold screws are your travelers. So that's a quick rundown of the GFCI lab for Unit 4, Lab 1. Again, my name was Mr. Sean. Please call me anytime if you have any questions or concerns, and have a good rest of the day. Thank you.